Hi everyone, welcome back to the channel. My name is Nitish, and in this video we're going to cover what are interfaces in Go. So we're going to cover a bunch of things in this video. First of all, we're going to cover what are interfaces. Okay, we'll be covering the what are the types, what are the values in those interfaces, that looks like, how do you define the interfaces. Okay, so a bunch of different stuff is going to get covered in this first topic, which is what are interfaces. uh, then we'll be covering type assertion, type switch, then we'll be taking a look at some standard interfaces, then we'll be doing some basic exercises so that we can understand how these interfaces are working. um, and at the last two parts, we'll be exploring an open source project, and we'll be seeing how interfaces are getting used here. So what happens in most of the projects, in any project you're going to see, interfaces are being used a lot. Okay, so we're going to pick just one interface. We're going to see why they have used interface here and how they're using this interface. And at last, we're going to build a very simple small project, which you probably can include, won't include in your resume, but you can get an idea on how we're using interfaces. So just note that before you start this video, this is the part one of the video, which is about interfaces. In the part two, we're going to take a look at some more standard interfaces. So although you have seen this topic, oh, wait a second, yeah. So although you have seen this one, I have mentioned that we're going to take a look at some standard interfaces, but we'll be covering a couple of standard interfaces in this video. A more detail about these standard interfaces, like other standard interfaces, that will be covered in part 2. This is going to be a pretty much, I think, a long video, but I assure you that if you stick till the end of this video, you will be going with bunch of knowledge about interfaces. And anytime you see any a code that is using interfaces in Go, you won't have a doubt anywhere else like that. Okay, so without any further delay, let's get started. So we're going to take a look at first what are interfaces. Okay, so what are interfaces? Let's come to an example here. I can give you an example here. So yeah, let me try to give you an example. So let's say that you have a TV remote. Okay, let's say that you have TV remote. Okay, so if you go to the TV remote, you see the images here. You see that this is basically a TV remote that has a volume up, volume down channel. You can change this, so it has different buttons, right? And you can use these you can press these buttons to basically increase the volume. You can press these buttons to decrease the volume. You can change the channel number as well. Okay, so now I'm saying this is your remote. Okay, fairly simple. This is your remote. Now this remote can actually work with anything. Now this remote, let's say, okay, yeah, let's say, so this remote can work with your any appliance. So it can work with your, let's say, AC machine, AC. It can work with your AC. Okay, why is it behaving like that? Anyways, so it can work with your AC. Okay, this remote can also work with your TV as well. Okay, this remote can work with your TV, and it can work with any other appliance. Okay, it can work with any appliance it wants to, like any other appliance. So let's say that there's a company called as LG. Okay, it created a remote, and it's saying that this remote you can use to this remote can be used to work with any appliance. An AC, it can work with the TV of type of basically of LG company. It can work with any appliance of LG company. So there's just only going to be one remote, but this remote is actually working with AC as well. This is the same remote that you can use for your TV. This is the same remote that you can use for any other appliance of the same company. The thing is, how is this possible? Like, how is this doing that? So this is okay. So this is what I have written here. This thing that I have drawn a line. This is actually is called as an interface. Okay, what is happening non-technically right now is this remote, which is this remote, this remote is going to have some sort of buttons, as you okay, a volume up, volume down, whatever, right, as you see here. So this remote is going to have some sort of buttons here. Now the thing is, this remote is satisfying this interface. How is this satisfying interface? That is another topic. We'll be taking a look. But what I'm saying to you right now is this remote will be satisfying this interface. Okay, if I mean, yeah, or I would say in simple terms, there is an interface, okay, in such a way that if AC, okay, if this AC or if this TV or if any other appliance satisfies this interface, how we're going to satisfy this interface, that's another topic. We'll be taking a look. But I'm saying if this AC or TV or any other appliance satisfies this interface, it means it's automatically going to work with remote. That's simple definition of interfaces. Interfaces is in non-technical ways. You can give an example that if AC or TV or any other appliance satisfies this remote interface, it's automatically going to work with remote. Okay, this is non-technical definition. Now you might ask me, Natish, how do we make sure like AC, can satisfy this interface? What is TV? TV can satisfy this interface. Okay, that's a one example that I have given you. Now let's take a look at some another example. You have switches in your home. So if I search for switches, okay, so you have different sort of switches here, as you see here. So you can see different sort of charges can work with these switches, right? What is happening? There's an interface and all these chargers are satisfying those interfaces. How they're satisfying is another topic again. But those charger, let's say Apple charger type, or let's say Samsung charger type or any other charger type, is satisfying that interface. Now if it's satisfying that interface, it's automatically going to work with that switch, as I have given you an example here in case of remote control. Okay, so that's a very non-technical definition. You might not have understood here what is an interface, but if I have to give you an example of what interfaces are, I'm just trying to see if my screen is perfectly visible there or not. Okay, so if I have to give you an example of what is an interface, okay, like what exactly is an interface, so I'll write it here. What is an interface? What is interface? Interface is nothing but just a contract. It's just a contract. So here what is happening is that this is an interface. This is just a contract. What do you mean by contract? Like I made a contract with you that you have to do this and I'll pay you this one. Okay, that's just a contract. So interface is just a contract between these two bodies. Which bodies? A remote and an appliance like AC. And what is this contract saying? This interface is saying that if this appliance AC satisfies this interface, I will work with you. I can automatically work with you. If TV can satisfy this interface, I'll work with TV too. If any other appliance can satisfy this interface, I'll work with that too. I'll work with any other appliance too. Okay, so interface is nothing but just a contract. Okay, interface is nothing but just a contract, and you can say that it defines a set of method signatures. What do you mean by method signatures? We'll be taking a look. So if you take a look at your volume, when I said you that you can increase the volume, you can decrease the volume. Think of these as like when you press these volume up, volume down button, right? There must be a function. There must be a function, right? That is being called example, right? So when you press the volume up button, let's say the volume up function is getting called. When you press the volume down function is getting called. Okay. Now what is interface is saying? Interface is saying I'm just a contract. All you need to do is define just a method signatures. Method signatures mean just tell me how the method is going to look like, how the function is going to look like. I don't care about how you have defined that method. I don't care about that. You just tell me how the method signature is going to look like. Okay, so how do you define an interface in Go programming language? We'll be seeing it right now. Okay, it's working perfectly well. Okay, so you generally so you define an interface. So we're going to say in Go programming language there's a remote which is of type interface. Okay, there's a remote type of interface, and now I'm saying this interface always defines a set of method signatures. So there's a method called as volume up. Let's say this is a method. Then there's a method, it has defined volume down. Very simple. Now what is going to happen is, now there should be types, right? Like this is a AC type, this is a TV type, this is any other appliance type. It needs to satisfy this interface. Now think about it. What I'm saying is, there should be a type like AC or a remote, or like AC or a washing machine or a television, that should be satisfying this remote interface. What is an interface? Interface is nothing but just a contract that defines a set of method signatures. You have defined an interface, and you have also specified the method signatures here. Now you have these are method signatures. Okay, you're not defining how the volume up button is going to look like internally, like how the body of this function is going to look like. You don't care about that. Okay, you just care about how the signature method signature is going to look like. Okay, now I'm saying here is that, let's say there are different AC, TV, and any other appliance. It needs to satisfy this interface. How can it do that? Now we come to this question: how can AC or washing machine or any other appliance can satisfy this interface? How can this satisfy this interface? You need to remember this one. Okay, any type can, or basically when I say satisfy, it simply means implement. Okay, how can you implement this interface? So any type can implement or satisfy this interface. Any type can implement an interface by implementing its methods. Okay, so let's say there's a type AC of type struct, like let's say type struct. This is a new type, AC type. Okay, AC wants to work with with the remote, but how can AC work with the remote? By satisfying this interface. How can AC satisfy? How can AC basically implement this remote interface? By satisfying by implementing its methods. So we're going to say A, which is we're just going to create a method here. Okay, and now you can simply say volume up. Let's say type AC, volume is of type integer. Okay, you can say volume is increased. Okay, then you can say function A, which is again AC, volume down, and dot println, volume is decreased. Okay, so now let's say there's a function called as change volume. It's going to take an interface. Now remember, it's going to take an interface this time, and now all you need to do is you can basically call the volume up or volume down. So let's say now you have a main function. Okay, you basically call the change volume. Now change volume can take any value, what is it taking? It's taking a remote interface. I'm saying it can, okay, so you need to remember that a value of any interface type, like a value of remote interface or any interface type, is equal to the type that implements it. Okay, a value, I'll write it down here. So you need to remember a value of interface type can hold any value that implements those methods. Okay, so in this case, AC is a type that implements volume up and volume down as well. So it means you can use AC here. Like if you create an object of type AC and you say the volume is going to be 12, you can simply pass AC here. Okay, why is it not getting passed? Implement volume down. Oh, so okay, sorry, it was already doing that, but we just had a typo here. Yeah, now it's doing that. You can see that we can pass the AC here. You can basically now pass any object such as washing machine. Okay, you can similarly pass change volume. You can pass appliance. Okay, any other appliance as well. But how is it doing that? all you need to do is just define your types. In this case, in this example, I defined the type as AC. Okay. Similarly, I can define a new type, TV, and any other appliance. And all these types needs to implement this interface. How can they implement any interface? By implementing its methods. That's how you do that. Okay, so now I have a change volume function that's taking an interface type, and I have told you, this is a very important thing, I have told you that a value of interface type, this value r of type remote, which is remote is of type interface, this can hold any value that implements those methods, any value that implements it methods. So this time I passed AC. How is it working? Because AC, what is AC? AC is of type struct. It's of type AC, right? Which is of type struct. And is AC implementing that interface? It can only implement that interface if it implements these methods. So as you can see, there's a volume up. So AC is actually doing that. Okay, there's a volume down, and AC is actually doing that. So that's the reason when you create an object of type AC, you can simply pass that AC value here. So if I similarly, if I take now, okay, one thing that I want to mention is when you go through any projects, you will see that most of these interfaces values are, being passed as structs. Okay, so what I want to say is that like let's say there's a change volume and you're passing AC, which is of type struct. Okay, here doesn't mean only the struct types can be used here. So let's say that I have a new type called as my number, which is of type float 64, and this type again can implement my, if it implements by method, then basically the same stuff. Okay, if it implements my methods, then I can use the my number as well. I'll show you just in a second. So again, this is going to be volume down. So you can see now you can simply say that there's a let's say there's a number which is of type my number 12. Okay, now you can simply pass a number to. Okay, this is also completely valid. Okay, so it doesn't necessarily mean that the only types that of type struct can be passed. No, what I'm saying is that in most of the projects, you will be seeing that in most of the places, struct types are been getting passed. Okay, it's not always the case. What I'm saying is any type that implements that interface can be passed, any type. So what I want to say in simple terms is that a value of interface type like r of type remote interface, it can hold any value that implements it method, any value. It can be of struct type, it can be of a boolean, it can be of any like string, integer, whatever it can be. Okay, that's the first thing that I want to talk about. Okay, so let me see if there's something else that I need to talk about. I think we're good. All right. So now another thing that I want to mention here is that
it's 11 o'clock.
Sorry for that. Yeah. So let's say there's a type I interface and there's a method M. What I want to tell you that these methods, these like when you say implement an interface in Go programming language, interfaces are implemented implicitly. Okay, not explicitly. What it means to say is that if you have come from any programming language like Java, you might have noticed that in order to implement an interface, you use the implements keyword. In Go programming language, you don't need to do that. Okay, all you need to do is if you have an interface something like this, like IE, which is of type interface, it has this method signature M, and then there's a new type T, which is of type struct, that has a field called as string. All this needs to do is satisfy this interface by satisfying its method. How to satisfy an interface? I mean, how to implement an interface? Any type can implement an interface by implementing its methods. Remember this. Any type can implement an interface by implementing its methods. So as you can see, T, which is of type T, is implementing that. So it's automatically doing that for you. So T dot S. Okay. So you don't specify any implements keyword. All you need to do is just implement it simply by implementing the method. That's basically called as implicit declaration. Okay, so yeah, there's no implements keyword, as I told about. So if I look at the main function, if I have to create a main function, what I can do is, let's say variable I, which is of type interface. Now this interface value can hold in I can be equal to the type that actually implements it. So this time I can be equal to T. Yeah, hello, this is completely valid. Why? Because if you see T, which is struct, it implements this interface. How is it implementing this I interface? Because it is implementing its methods. So there is only one method M, and you can see that this type is implementing that method. Okay, so if you now call that, here you go. If you run it, you can see hello is getting printed perfectly well. Let's move to the next topic, which is about interface values. This is very important step. Okay, um, I mean, let's only take this example. Okay, so let's talk about. I'm going to describe this interface now. So I'm going to introduce a new method, new function called as describe. That's basically going to describe the value and what is the type of the interface. Like for example, you know that if you have a variable of type, like let's say, okay, let me give you an example. Let's say there's a new variable called as num is equal to 12. You know that num is of type integer and its value is 12, right? Now I'm asking you, what is the type of I, what is the type of interface, and what is the value of the interface? Think about it. So in order to do that, I'm just creating a new function called as describe that's taking an interface. Okay, that's basically taking an interface, and I'm going to simply print it. Okay, and let's try to print it. So percentage v comma percentage t. That's it. So I comma I, and yeah, let's describe I. Let's try to run it. Okay, what is happening? Let's see. You have defined an interface is now, you in already mentioned that interface value is equal to any type that implements it. So this time T was implementing it, so now so it's valid. This line is completely valid, and now you're trying to describe that interface. Percentage v is printing that interface value, and percentage t is printing the interface type. Let's try to run it. Okay, you see this output. What is this? What is this happening? Like what is this thing? You see the value is getting printed as hello, like this is of struct type. Okay, and the type is main.t. Okay, what is happening is that under the hood, let me just write it down for you. So under the hood, interface values can be thought of as a tuple of value and a concrete type. Okay, this is a very important line. Tuple of value and a concrete. Yeah. Okay, so yeah, that's it. So if when someone asks you about what is the type of interface, the type of the interface is dynamic in nature. What it means is that an interface type can vary, and what is the value of an interface? It's also dynamic. So let's write it down. Interface type and value are dynamic in nature, which means they can change. Okay, why? Because interface type is always going to be the type of the type that implements it. Okay, so in this case, what is the type of the interface? It's going to be of type struct, like the T. Okay, that's the reason you see main.t was getting printed here. Why? Because this time it's equal to this one, right? So it's the only thing that's basically, satisfying it. So the type of interface automatically becomes the underlying concrete type, which is what is that? Which is that main.t. When you see main.t, it simply means like there's a package called as main, and in the package there's a type called as t. That's what it simply means, main.t. Okay, and what's the value? of an interface, a value of an interface is going to be the value of the type that implements that interface. So in this case, you see this was a type. Which was a type? Main.t, right? And what's the value going to be? The value is going to be the one that you've specified here, hello. That's what is getting printed. Okay, so that's it. I mean, very simple step. So that's what I wanted to mention. In under the hood, if someone asks you what are interface value and what are interface types, an interface is, so interface value is going to be the value of the type that satisfies that, I mean that implements it, and the type of the interface is going to be the type that of, it's basically going to be the type of the type that implements that interface. Okay, so let's take an example more. Let's say that there's a new type called as f, which is a float 64. Now there's a method m. So what I'm going to do is, let's say it's now this f is implementing it. Why? Implementing the interface. Why? Because it's implementing the method. Okay, so if I say I is equal to f of 12, and then I describe I, and then I dot m. Now let's try to see again. Now let's see. So this is fairly valid, but now you see interface value got changed. See, initially the interface value was hello. Now interface value is 12. The value is getting changed. That's the reason I already have written here. You know that these are dynamic in nature. It can change. So interface value this time is 12. Why? Because think of it. Why is it 12? Because this is f. So okay, let's come to type first. What's the type of the interface going to be? The type of the interface is going to be the type that satisfies it. So if in this case, which is f, right? So it's going to be main.f, right? What's the value going to be? The value is going to be the one that you have provided here, which is 12 in this case. Simple. Okay. So one thing that I want to mention, let's say that here you specify t in which is a pointer to t. Okay, example. All right, let's say that you specify a pointer to t. Now this is completely wrong, right? Because if you look at the error, cannot use t, type t as a type. Type does not implement I as m, as method has a pointer receiver. Exactly. This method is having a pointer receiver. Okay, so if you want to satisfy this, I can only be equal to t only and only when there's not a pointer receiver. If there's a pointer receiver, all you need to do is basically point it to the actual address. I mean the value that's getting stored at that address. Okay, so that's how it's basically done. Okay, now perfect. So these are called as interface values. Okay, now let's take a look at, let's continue this example. Okay, this time you can see that I is basically equal to, it's basically equal to t, right? And you can see that there's a pointer receiver, right? That has a hello string. Okay, so t is just a pointer that is pointing to what? Hello right now. My question is, what if t is a nil pointer? What if t isn't pointing to anything? Don't say, Nitish, I can do something like this. No, this is actually pointing to an empty string. Okay, this is not something that you can say. T is a nil pointer in this case. No, it's not. Why? Because it's pointing to an empty string. I'm saying, let's say there's a pointer called as variable t, which is a pointer to t. Okay, this time you do I is equal to t, and now you try to describe I, and then you call I dot m. Okay, this is what I want to tell you here. Understand this. Okay, and since it's so if t is a pointer, let's add a new case. Let's add a switch statement, not a like if statement. If t is a nil pointer, if t is equal to nil, simply say nil. Okay, and return. Very simple. Now let's try to run this. You see nil is getting printed here. That's what I wanted to mention. So in this case, I is equal to t. What is t? T is a pointer, right? You can see it's okay. So you tell me, is this code correct? I is equal to t. Why? T is basically pointer to t. So you're saying interface value I is equal to a type. Basically, I is going to be of type t. Basically, going to be of pointer of type t. Is this correct? Let's see. Is there any is okay? So is t implementing that interface? Is type t implementing that interface? It is implementing this interface. You can see this is how it's implementing it. So this is correct, right? This line is correct. But the thing here is this time t is a nil pointer. Okay, t is a nil pointer. T is not referring to anything. It's referring to nil value. So we just added a new condition that if t is nil, just print the nil value. So that's what you saw here right now. That if you try to describe it, what's going to happen? Um, what's the interface value going to be look like? The interface value is going to be nil. Interface type is going to be main.t. Okay. A very important thing that you need to know that an interface that holds a nil value is itself non-nil. Okay, even though this interface, understand this, even though this interface, where is it? Yeah. So even though this interface is sorry, yeah. So even if okay, why is this happening to me? Okay, so even this interface is holding a nil value in this case, right? Because t is a nil pointer, right? The interface is actually non-nil. Okay, you can't say interface is nil. No, interface is non-nil. Interface value is nil. How do you determine the interface value? It's the value of the underlying concrete type. Okay, so in this case t was a pointer which is pointing to nil, so interface value got nil. But is interface nil? No, it's not. Okay, so it's very important to note that an interface value that holds a nil concrete value is itself non-nil. Okay, that you need to know that. Okay, that's fairly simple. All right, let's move to let's I just want to mention that. Okay, so since t was pointing to nil, we printed the nil value. That's very simple. In some of the programming languages, this can give you some sort of error. Okay, so this can basically trigger like a null pointer exception. But in Go, it's very common to write method that is basically handling the call with nil receiver. Okay, so you can have these checks like if t is equal to nil, then do this. But in other programming languages, it doesn't support that. So in other programming languages, you're going to get an error, or I would say you are going to get a basically panic, or like a null pointer exception. Okay, so yeah, now let's move to another topic, which is called as nil interface values. This is very simple. Let's say that there is a type which is of type interface, there is a method m, then again type t, struct type, and then there is a s which is of type string. Okay, there is a function main. What is a nil interface? Think about it. Like nil interface values. What do you mean by nil interface values? Nil interface value simply means any interface, like any interface that's basically not getting implemented. Okay, so in nil interface means like, so it's not going to hold neither a value nor a concrete type. So if there's no type that implements that interface, that's like a nil interface. If there's a no type, if there is no type that implements that interface, it means that interface is nil interface. Okay, so like in this case, there's a type I interface, there's a struct, but it doesn't, I'm not going to implement this interface. Okay, so let's say what I'm going to do is I'm going to take I, which is of type interface here, and I'm going to have describe I, which is of type I interface, and let's see, percentage v comma percentage t, sorry, percentage t I comma I. Okay, here you go. Here you go. Perfect. Okay, so now let's say that you describe the I. What is going to happen? Let's try to run this. Nil, nil. Why? Because now it tried to print the value of the interface. Is there any type that implementing it? Think about it. Is there any type? I already mentioned it to you that an interface value is equal to going to be the value of the underlying type. So is there any type that implemented it? No, there is not. That's the reason you see the type is nil. So is there a value? No, the nil value. Very simple. Okay. So yeah, one thing that I want to mention. What if you do something like I.M now? What's going to happen? Think about it. Since there is a no type that implements this interface, what should happen? Should this method get called? Now you might ask me, Nitish, there's no type that's basically implementing this interface. Then how is this possible? Like, how can you call this method? There should be some sort of error, right? Because you can't call this method. Why? Because there is no type that's implementing this. Think about it. I mean, some people might have doubt here. When you say I.M, what's going to happen? Internally, method M is going to get called for it of a type, right? Let's say there's a type E struct. If it implements that method, then automatically that methods is going to get called, right? But since there's a no type that implements this interface, Go compiler doesn't know which method to call here. So it should basically give you a panic sort of, right? So if you try to run this now, you see there's a panic. Invalid memory address or nil pointer dereference. That's an error. Why? Because there is no type inside this interface to indicate which method to call. Okay, but if let's say that now this time there's a type T struct, if I simply say function M and I simply satisfy this, now this type is implementing it. Hello. If I now try to run this, oh sorry, yeah, so I is equal to type hello. I mean, I can simply say hello. Yeah, you can see hello is getting printed here. Okay, that's perfect. Why? Because now this time when you call I.M, Go tries to see, okay, Go, what compiler is seeing that, okay, the underlying type of I is basically of type T, right? It's of type T, and T is basically implementing that. So I just need to call this method. That's basically using this T as a receiver. That's what it's doing here. Okay. So what is happening? The compiler is internally seeing what is the type of this interface. It's of type T, right? It's of type T. I mean, it's of type struct. It's of type struct, not T. Okay, so it's of type struct. I mean, okay, you can see that it's of type T or it's of type struct, whatever you want to say that. But let's say it's of type T. Okay, what I'm saying is that now when you call I.M, it sees, okay, I is of type T. That's very simple. I is of type T now, and all it needs to now call is the method that is having T as a receiver. Which method is having T as a receiver? Which M? This one. That's what it printed, T.S. What is this value? Hello. That's what it got printed. But now if I just remove it, do you think there's something going to be called here? No. Why is this happening? Because I, which is of type interface, you have not, it's right now it's a nil interface. Because although there's a method, there's a type that satisfies it, but you haven't like right now it's a nil interface. Right now it's a nil interface because you haven't assigned it a value. Okay, so that's it. That's about the nil interface values. Let's talk about another easy concept. If someone asks you about this is basically nil interface. Okay, what is nil interface? Nil interface is basically an interface that's going to have a nil type and a nil value. How it can have a nil type and a nil value? It can have a nil type and a nil value when uh, when basically either no type is implementing that interface, or even if a type is implementing its interface, you are not you are not assigning that value to that type. Okay, you're not assigning the value of that interface to the type. So in this case, even though the type t was implementing it, but you are not assigning that value of interface is equal to like something like this. So what is a nil interface? Nil interface is simply an interface that's having a nil type and a nil value. Okay. Now let's talk about something called as empty interface. Very important. Again, very simple. We're going to talk about empty interface. Okay, again, type I, which is of type interface, method m, and type t, struct s, which is of type string. Again, so what is an empty interface? Let me write it down. An empty interface is a interface that has zero method signatures. Is I of type interface an empty interface? No, it's not. Why? Because it has a method m signature defined. Is I of type interface now an empty interface? Yes, it is. Why? Because this time this interface is having zero method signatures defined. Okay. Let's say function main. Okay. Now let's say variable I of type interface. Okay. Now, very important thing that you need to understand here. Very important thing. Okay, any interface that has zero method signatures or basically specifies zero methods is an empty interface. So an important thing that I want to mention is like an empty interface can hold values of any type. What it means that I can be 43, I is equal to hello is also valid, I is equal to false is also valid. You see, like my code editor is not giving me an error, even though now I am assigning the value as 43, hello, false. Why is this happening? Like, why does an empty interface can hold value of any type? So think about it. It's because every type implements at least zero methods, right? Every type implements at least zero methods. That's the reason you see 43, which is of type integer, is implementing zero method at least, right? At least zero method implements. So that it means it implements this interface, I interface, right? So now since it implements that interface, its value is going to be 43. Similarly goes for the string, similar goes for the bool value, and similarly goes for any type. Any type, let's say I is equal to struct hello. Okay, let's take an example. Let's say again describe I, which is of type interface, and percentage %v comma percentage %t. Let's now define, let's try to describe the interface. Let's describe it, let's describe it again, let's describe it again, let's describe it again. Now let's try to run this. So you see, the first time it has a value called as 43 of type, and the type of the interface was integer. Now it has a value hello, the type was string. It has a value false, type was boolean. Now it has a type struct, the type was t. The value was hello and the type was main.t. Okay. You can, okay, so one thing that I want to mention, that you can also write this code as something like instead of defining interface like this, you can simply say, you can also describe it as variable I, which is of type interface. Very simple. This is an empty interface. Why? Because it has a zero method signatures. This is also valid. Okay. Now you might ask me, how do you do that here? Like, you can simply say I of type interface. That's the very simple thing. Okay, so you can do that. Now you know about what is an empty interface. Okay, so you know that any interface that has zero method signatures is called as an empty interface, and an empty interface can hold value of any type. it can hold a value of integer type, it can hold a value of hello type, or like string type, it can hold a value of boolean type, any type it can hold. Okay. Now the question is, Nitish, why do I need empty interfaces? Like, what's the use of that? So what happens is, so generally empty interfaces are going to be used by those pieces of code that needs to call, that needs to input, like that needs to have inputs of multiple types. Okay, for example, if you look at the print method, or let's say println method, okay, or if you take a look at the print method, okay, if you look at the print method, it's taking a, which is like a, it's taking bunch of values. Okay, it's taking a number of values of type any, when wherever you see any, it means like any type, which means interface. Okay, so whenever you see any here, any and interface are almost same. Okay, so when, if you see here a, which is like it can be of it can take any types, it means like it can take any interface types. Okay, interface values, sorry. Okay, so yeah, as you can see, print, you can, so print is taking any types, so you can use hello, you can print hello, you can print well, you can print false, you can print, I mean, if there's a type, whatever you want to, this is completely valid. You see, this is completely valid. So an empty interface is basically used by that piece of code that needs the access to, of, that needs access to variables of any type. Okay, in this case, print needs the access to all the types, so that's the reason any type, any was used here. Okay, similarly goes for the println. You see, it's taking a any types. Okay, so it's taking multiple elements of type any means like interface, empty interface. Okay, so it's taking any number of arguments of type interface. Wherever you see any, it means interface. Now okay, so listen to this. Now we're going to move to another topic. We have covered bunch of stuff here related to what are interfaces. Now it's time to move to type assertion and type switch. It's very simple now, very simple. I'll tell you why do we need type assertion now. A lot of people get confused as like, what do you mean by type assertion, why do we need it? I'll tell you in very simple terms. Now the thing is, you see that there's an empty interface. It can hold 43 value, it can hold the string value, it can hold the boolean value, it can hold any type value, right? What is type assertion? Let's understand first of all. Let me just remove the extra piece here. Okay, yeah. So what happens is that we're going to talk about type assertion. Okay, so what is assertion here? Assertion, let me see if my, yeah, it's working well. Yeah. So assertion in very simple terms is like making a statement that's either true or false. You're just making a claim which is either true or false. An example of a claim or an assertion is a statement that's either true or false. It can be, for example, I have subscribed to Nitish's channel. That can be true or that can be false. Another statement can be, I am a pro at Go programming language. That can be either true or that can be either false. Another can be, I am very rich. That can be true, that can be false. These are assertions. You're making an assertion. Like, for example, you said, I'm very rich. Now, this statement can either have a true value or can have a false value. It can't have like a both values. Okay. So that's what we call as assertion. Assertion is just a simple statement that's holding, that's basically having like either a true value or a false value. What do you mean by type assertion? In simple words, type assertion means now you're going to make assertions or the claims against the types. What do you mean by that? For example, you can say, is I of type 43 or not? True or false? I is of type string. I is of type float. I is of type bool. I is of type anything, etc. etc. Okay. Now, when you say I is of type string, this can be either true or false. I is of type integer. This can be true or false. I is of type um, struct. This can be true or false, right? This is type assertion. Okay, you're making an assertion against the type of I, which is an interface, which is an empty interface. Okay. um, Another important thing, very important thing, what's the use of type assertion? So a type assertion provides you access to an interface values underlying value. What it means to say is that, let's say I is equal to 43. Okay, let's say I is equal to 43. In order to fetch the value of the I, in order to fetch the actual value of the I, which is 43 in this case, you can use type assertion for that. Now you might ask me this, why do I need to like do that? Why do I need to fetch the value? So if you look at the large code bases, you will be seeing type assertion is getting used heavily, and you don't know what's the value of the IE that's coming from the previous method calls. Okay, so let's say there's a method call A which is calling B, which is calling C, which is calling D. Okay, you don't know, and in all these methods, let's say type assertion is happening. There's a interface type, and interface type value is getting changed, and you don't know what's the value right now. So you need to you need to fetch the actual value of I right now. How do you do that? You do that with the help of type assertion. Okay. How do you do that is the main stuff now. Very simple. So let's say that there's a variable I of type interface, and I can hold a value of type string. Let's say example. Now we're going to make a type assertion here. How do you make a type assertion? Is this is how you do that. I dot t. Understand this, very simple. What is t here? T is a type. T is a type. T can be string, T can be integer. So here T can be string, int, bool, whatever it can be. T can be anything. So what is I? I is an interface. I is an interface. What is T here? What is small t here? Small t is actually the underlying interface value that you can fetch. So in this case, you're going to make an assertion. How do you going to make a type assertion here? You're going to say that value is equal to I dot string. You're saying that I'm going to make an assertion that I is of type string, and put the actual value of I, which is of type string, in the variable value. Put the actual value inside the value variable. Okay, so if I print the value, go run main.go, hello is getting printed. Why? Because you have defined it here. Very simple. Because you know that this was hello, you have defined it. That's okay. But what if you do something like this? I mean, let's not do like this before we jump into that. So right now you have defined only one variable on the left side. You can have one more variable, something called as OK is equal to I dot string. So this OK variable is just telling you that whether I is of type string or not. OK is just a variable that's telling you whether I is of type string or not. That's a very simple thing. Okay. So if OK, if I is of type string, if I is of type string, then OK is going to be true. If I is not of type string, OK is going to be false. But when OK is going to be false, what's going to be the value? The value is going to be the default value of type t, which in this case is string. What's the default value of string? Empty string. Okay, let's try to print this. Let's see. Hello got printed and true. Okay. Yeah. Why? Because OK was true and the actual value got printed. But let's say now you have defined a. Let's say that you have defined now you're saying I dot integer. You're now making an assertion that it's going to be an integer. So new value comma OK. fmd dot println new value comma, okay. Now you tell me, is I of type integer or not? I was of string. Is I of type integer? No. So OK is going to be false, but what's the value going to be stored in the new value? It's going to be the default value of type t, which is integer here, right? What's the default value of int? 0. Let's run this. You see 0 is getting printed and false is getting printed. Now you might ask me this, what if I do something like this, I dot integer, and now I simply try to print it. Think about it. Is I of type integer? No. Do you think the default value which should get printed? You might think, but it doesn't work like that. When you're not using the OK variable, when you're not using this bool variable, when you're not defining this bool variable, okay, and if this assertion is wrong, and you're not obviously defining this bool variable to determine if this assertion is correct or not, then Go will give you a panic. Okay, you see, interface conversion, interface is a string, not int, so it's going to give you a panic here. If you want to get rid of this panic, just use OK here, okay, or just simply use, you can do something like this. Okay, that's basically called as type assertions. So yeah, let's now move to another topic, which is type switches. Very simple. So now, okay, so now you're making an assertion that I is of type string. If I is of type integer, do this. If I is of type bool, then do this. If I is of type bytes, do this. If I is of type slice, do this. Example. If you have to do something with all these types, like let's say if I is of type string, print the string value. If I is of type integer, print the int value. If I is of type print this value. So there's going to be multiple if else statements. How do you get rid of all these if else statements? With the help of switch statement. But the only difference that's going to come in case of type switches, let me just write it down here. We're going to talk about type switches. Okay, function main, and again, yeah, so we're going to talk about type switches. What is type switch? Type switch is nothing but you can think about is as a construct that permits several type assertions in series. So if you want to do multiple type assertions in series, like if this is correct or not, if this is correct, if I is of type string, if else if type, sorry, if I is of type string, else if I is of type integer, else if I is of type a bool, do this. Example. Okay, so it's just type switch is just a switch statement. It's just a switch statement, just like a very simple switch statement. All the difference that's going to come is that the case in this switch is going to hold types, not values. So in normal switch statements, you know that the cases are going to hold the values, but this time in switch statement, the cases will be holding types. We'll be taking a look at it. So let's say I create a new function that says describe, not describe I would say, but determine type. Okay, I which is of type interface. Now there's going to be switch. So what's the expression going to look like? The expression is going to look like this: I dot type. You're just making a type assertion here. You're saying I'm going to make a type here, and now in the case there's going to be, so the case is in this switch is going to hold types. So for example, the case can be here integer. If it's an integer, print this is integer. It's an integer type, and print the value of the integer type. Case is string. This is my string type. And then if it's of type bool, either print either true or false. And if there's any other type, you're going to say I don't know the type. I don't know the type. Let's print. Okay, so now this is type switches. Okay, so determine type, and let's say that you can call 2012. Then determine type, you can call hello. Determine type false. Let's say there's a new type t, which is of type struct, but now so you can call this type. But let's see, let's try to understand. So this function gets called. You see that this is integer type, this is string type, this is string type. Oh, why is it getting okay? Yeah, false. Either true or false. The false value, I don't know the type. Very simple. So this is type switches. Okay. So know that this syntax is almost same like type assertion as we discussed previously. Only difference is in this case we're using type when we're using type switches. In case of in type assertion, we generally specify the type actually. So now this type is basically getting matched against this case. Okay. So yeah, that's it. Um, Now let's take a look at some standard interfaces. Okay, so one of the standard interfaces that you can take a look at is the stringer interface Golang. So if you see, if like they give pretty good example that there's a stringer interface, which is a fundamental interface defined in the FMT package of standard library. It eventually allows you to it allows custom types to define their own string representation when used with functions like print, println, and things like that. We'll be taking a look now. Okay, so there's a stringer interface that has this method. Okay, so let's say, oh, by the way, I just want to mention that if you go to the print function, you see that print is calling this function fprint, it's calling this do print, it's calling this print arc, and you see this is where the type assertion is happening. You see a lot of type assertion, or I would say type switch is there. Okay, so you see bunch of cases are there. You don't want to use if else, if else, if else. Okay, so that's the reason you use type switches in this case. So fm2 print is eventually doing that for you. So there's a stringer interface. A bunch of these interfaces, like detailed discussion, is going to be coming in the next video, but we'll be taking a couple of these famous interfaces right now. So there's a interface called as stringer interface. Okay, stringer interface. Yeah, let's take a look at this. So yeah, there's a stringer interface that eventually allows you to customize how the values are going to get printed. So let's say there's a function main. If you want to print hello world, it's going to get printed like this very simply. Let's see how long the video is. Oh, okay, cool. So it's very simple, it's getting printed like this. Go run, very simple, right? Let's say there's a new type, or let's say okay, there's a type p which is of type person and struct, and this is having age which is of type integer, name string, and it's going to implement this interface. So function string so you can simply say %v is old, p dot h. So let's say right now, let's say right now it doesn't implement it. If you were to print the person value, How will you do that? Let's say the name is going to be like let's say the age is 21, name is Nitish. If you simply try to print it, it's going to be get printed in this way order 21 comma Nitish. Now let's say it implements it. This type implements it. And now let's see how is this getting printed. Nitish is 21 years old. What is happening? So what happens is that whenever you okay, and let me just pass one more thing called as hello world. Here you go. Hello world is getting printed here as very simply as it is. Okay, but when you try to print person, it's printing this way. What is happening? Now, whenever you call the println method, what happens internally inside the println method is that it takes a variable at a time, right? So you can see println, what is it doing? It can take any number of variable of type any, right? So it takes the first variable, which is of type person. It sees, it checks whether this type implements the stringer interface or not. If it implements the stringer interface, this is the exact message that's going to be getting printed. That's the exact message that will get printed. So this time it sees, is person implementing the stringer interface? How can it do that? It can do that by implementing the string method. Is it implementing it? Yes, it is. So this means this line is going to get printed. Now it comes for the hello world. It's going to see, is this string actually implementing, it's of type string. Is string implementing the stringer interface? No, it's not. You see, do you see that I have basically implemented it? No. So it's going to basically print it as a default value as it is. Okay, that's a simple example I can give you. A stringer is just a type that can describe itself as a string, and the fmt package looks for this interface, which is a stringer interface, to print values. Okay, very simple. So yeah, let's see now. Let's take an example here. So there's a problem statement that there's a problem statement. Let's solve this problem statement. Okay, so we have this problem statement and we have been given this piece of code. You have been given IP address, which is of slice of, which is an array of bytes of length 4. You have a host that is going to be a map. The key is going to be string. For example, the string is Google DNS, and the value is going to be an IP address. IP address inserts of type slice of bytes. Okay, and then you're just ranging over the hosts array. Okay, I mean the map, and then you're just printing the value. You're first printing the name, which is string, and then you're printing the IP address. Okay, now it's saying you that make this IP address, which is 127,0,0,1, implement the stringer interface to print the address as dotted query. Something like IP address of 1, 2, 3, 4 should print it as 1, 2, 1.2.3.4. Okay, if I print it right now, what's going to happen? It's printing 127,001. We should print it as 127.0.0.1. Okay, how can I do that? So you need to make sure this type implements a stringer interface, because you need to customize the value. Okay, right now you see IP is getting printed, right? And this IP, so if you can implement this IP address, like if you can implement this stringer interface by implementing string method, then I think the problem will be solved. Let me just try to show you how we can do that. But before jumping on that, I would recommend you try doing it yourself before you see the solution. All right, so let's say there's a string and string IP address. Okay, let's say it's simply hello world. Let's say it simply prints hello world. What's going to happen? Hello world is getting printed. Why? Because we are ranging over the host. What's the value of IP going to be? The IP is going to be of IP address. So when it tries to print IP, it sees whether this IP is implementing the stringer interface or not. It implements it how? By implementing the method. So it simply returns that hello world. Okay, so when it tries to print the name, which is of type what, string, it sees, does this implement my stringer interface? No, it doesn't. So it prints the default value. Then when it comes to IP address, it tries to see whether this IP, which is of type IP address, implements a stringer interface. It does. Then instead of printing the 127, it simply prints the hello world. Our question is that we need to what we basically need to print the values as dotted. So one thing that I can think about is you can simply do it something like this: percentage d comma percentage d comma percentage d comma percentage d, and IP address 0 comma print the print the element and print the fourth element. 1, sorry, all right. Too many arguments. 1, 2. Oh, sorry. Okay, here you go. If I try to now print it, you see 127.0, it's working well, right? That's one solution. What I did is just simply print it as a decimal format. Okay. Another solution can be create a new array. Let's say call it as parts. Okay, and this parts array, what's type it's going to be? It's of type string, um, slice of string, and length. What's the length going to be? The length IP address. Then just simply range over the IP address. Okay, and just say that parts at that key is equal to be like is you just need to, you can simply say percentage d comma value. Right now the parts array is going to be having 127.0.0.1, but parts will be a string, it will be an array of type strings, right? And then simply return this, call this method joins and parts, and separator is going to be dot. If you look at the joins, this is taking a string array and it's taking a separator. So let's say that the string array is foo bar bars, and you have specified a separator as comma, then this is output foo comma bar comma bars. That's what I've done. We created a new array called as parts of type of like an array of strings, and then we simply put those elements, we just range over the IP address, and we simply put those elements in our string array. Okay, and then we just pass that array to this function and added a separator dot. Let's see, running well. Okay, that's a stringers interface. This new interface is another interface which is called as, I mean, okay, there's another interface which is errors interface. If I show you here error interface, go along. So there's a new interface. If I yes, if you see, this is an error interface. Okay, the error type is an interface type, and error variable represents any value that can describe itself as string. Okay, so what I'm going to do is, um, let's say there's a um, let's say there's a type my error, which is of type struct. Okay, there's a function main. Okay, what's going to happen? Let's say there's a function called as run that going to give you an error. Okay, so um, return fmt dot, I mean return fm dot. So let's say this type is implementing that interface. Okay, error interface. How is it going to do that? Is my error, and we simply say fm return fm dot error. Very simple. Okay, let's say there's a run function that's simply returning an error, so we simply say return my error. This is valid, right? It's returning error. What is error? Error is of type interface, right? So it means it can return any value, any type that implements that interface. So my error we are returning, is my implementing that error interface? Yes, it does. How? By implementing its method, which is a method error string. It's implementing it. That's the reason I can simply return my error here. Now the question is, let's see, if error is equal to, let's call the run method, and we say error is not equal to nil. So if error is not equal to, obviously error is not equal to nil, we're just going to simply uh, print the error, okay, and return. What's going to happen is println is going to see error, okay, it's of type error interface. It's going to see whether this error interface is getting implemented by any type or not. If it does, it's simply going to print that message. Okay, so it sees there's a type called as my error, and yeah, there's a type called as my error, and it's going to simply print that for you. Go run main.go. Very simple to how we did in the previous example. So there's a stringer interface and then there's a error interface. So we have covered, I think, bunch of stuff right now. A few things that we need to talk right now is about some standard interfaces. We take a look. We'll be covering bunch of standard interfaces in part 2. Now we did some few exercises too, and now it's time to complete the last two part, which is explore an open source project and building a small project. Okay, very simple. So I'm going to take a look at Argo CD. I would recommend you going through the Argo CD code base. Just search Argo CD GitHub, and we're going to take a look at it. Okay, so just go through Argo CD. I have already cloned it, as you can see, and I have opened a new file. I have opened the file util-cache client.go. So if I search for client.go util-cache client.go, you can see this is the file that I've opened, and there's a cache client interface. Okay, if you see, this cache client interface is satisfying bunch of methods, like it has defined bunch of method signatures like set, rename, get, delete, right? If I click on any of it, you can see that a lot of clients like in-memory cache client, Redis cache client, two-level client is implementing it. Okay, what is going to happen is that what they have done is, like, they are using this interface, and since there can be multiple clients that eventually needs to have the same sort of properties, like like have, set, rename, get, delete, own, updated, whatever, it simply created these interface for you. And any type that wants to use use this interface, like use this sort of interface, all it needs to do is just implement that, implement its method.
It's 12 o'clock.
So if I take a look at Redis cache, you can see it is implementing all the methods here. Okay, similarly, if you want to take a look at rename, let's say in memory cache, it's already doing that for you here. In the redis.go, you can see that there's a function called as new redis cache that's returning you cache client, which is of type interface here, right? Let's see where is this. Okay, so it's returning you and of redis cache. If you see redis cache struct, it's basically of type struct. How is it possible? It can only be possible when this type is implementing that interface. Do you see this redis cache implementing it? Yes. Let's see where is this redis cache type implementing it. You see, it's redis cache set, redis cache get, redis cache. So that's the reason you see redis cache was returning this. Okay, if I see where is this getting called, let's say it's getting called here. You see abstract cache dot new cache. You're creating a new cache here, and you're passing a new client here. Like this time you're passing the redis cache client here. Okay, how is it possible? If you look at the new cache function, this is taking a cache client, right? So So it means it can only take any client that satisfies that. I mean, it can only take that client which is going to satisfy that interface. So here you took a Redis cache client, and you see that since it was satisfying it, it was creating this method for you. It was creating a Redis cache. Similarly, there you can simply create a uh, in-memory cache client, right? If you see new in-memory cache, you can see that it's returning you a pointer to in-memory cache, which is of type struct, right? Which is of type struct. So it is implementing this, all the methods. That's the reason this is also completely valid. Okay. What is the error here? It's not an error actually, but it's simply saying you're not passing the enough arguments to this call. So you just need to pass enough arguments, but that's also valid. So that's what I wanted to mention to you. Remember in the starting, I told you about a lot of times in the code base, you're going to see an interface is getting satisfied by a type which is of type struct. It's not always the case. Like in this case, if you see new cache, it's returning you not this, but let's say this example. So it's returning you cache client, and it's simply returning you Redis cache. So in this case, Redis cache is of type struct. This is implementing that interface, this type. Similarly, in case of in memory, this is again of type in memory cache. This is returning in memory cache, and see if you see all these are implementing that interface, and this is also of type struct. Okay, so it doesn't necessarily mean that only and only struct types can implement the interface. Any type can implement the interface, as we saw in our video in the code that we have done so far. Okay, so that's a misconception, not a misconception, but just want to bring this up. And now I think it's a time we build our project. I would recommend you going to this code base if you are interested in it. Try to see how interfaces are used, and I think it will be very easy for you to understand this. Okay, so we're going to build a payment gateway. Very simple. So now you can do payments by credit card, you can do payments by debit card, you can use Stripe for payment. So what I'm going to do is I'm going to define a payment interface. Okay, and it's going to have a method signature, pay integer. Then simply I'm going to have a credit card struct. I'm going to have a credit card type, and then pay amount, which is of type integer. Now this is implementing this credit card struct is implementing that method. So you simply run dot println amount paid by CC. How much amount? C dot, not C dot, but um, amount. Similarly, there is a debit card struct. There is a debit card type, which is of debit card. Amount paid by debit card. What is amount? This one. And similarly, you can have Stripe interface, not Stripe, but struct, and then you can simply say Stripe, and then you can simply implement it. Amount paid by Stripe amount. Okay, and then you finally do like make a checkout function that's going to take this implement that's going to take then payment interface, and all it needs to do is call the pay method. So let's say function main, you need to pass amount here, because so now I'm going to create a credit card here. Credit card is equal to this much. Then you create a debit card, that you create a Stripe account. Okay, and all you need to do is just check out, and you need to you can pass C. You need to pay 1200 by credit card. You want to check out 1500, and then you want to check out uh, 2000 by Stripe. Okay, so if I try to run this, amount paid by CC, amount paid by DC, amount paid by Stripe. Okay, fairly very simple. Just want to tell you how we're using interface. We are having an interface that's basically just a method signature. Then you have a type that implements it. Now this logic can be expanded based on your use case. A lot of it can be complex, but just want to keep it very simple to you to make sure you understand how we're using interfaces in that. Now before you leave, I have a few things that I want to mention. The first thing is, this is going to be part 2 of this video, where we'll be talking about some standard interfaces. Make sure you watch that part. Second is, once you have completed watching this video, spend some time playing with interfaces. I would highly recommend you going through go.dev. Like, all the links will be given in the description, so you just can access that. So go through those. It's very important to go through the official documentation and try to understand, play with that. Go through some open source project and see, like the one that I give an example, see how they're using that interface. Okay. And lastly, if you want to get connected with me, my all my handles are given in the description, so you can probably get connected with me. And if you have any doubts, post them in the comments or reach out to me. I'll be happy to answer that for you. So that's it for the video. I hope you guys really liked this video. If you guys do, make sure you hit the like button, subscribe to the channel, and I'll see you in the next one. Bye bye.